Hello everyone and welcome to my channel. Today we are going to build a front-end system design for chat application. So let's design a smart and scalable line system from the ground up. Our first limit is maximum 100 chats per user. So let's add our first limit, max 100 chats per user. Every chat needs space for text, info and history. With no limit, the database grows too big and slows down search. A limit keeps storage small and stable. The next one, max 100 people in one group or chat. Same as above. Large groups make storage and message sync heavy. This limit keeps load under control. Next one. We'll delete chats after 6 months of no use. So delete chats after 6 months of no use. All chats take space and slow the app. After delete, save space, remove noise and keeps the app light. Next one, small budget. We must build only what matters most. We focus on solid text chat first. And as you understand, no audio or video calls. No audio or video calls. Live calls need big infra, high speed and more funds. For now we stay with text only. Now let's talk about functional requirements. Our first requirement is search visibility. Since this is a chat app, we need a way to look up someone to start talking with. But at the same time, not everyone wants to be pinged by strangers. So users can choose whether they show up in search or stay hidden. The next one is invite flow. Once we find someone to talk with, we can just start typing. The other person has to accept an invite first. If they accept, the chat opens up. If they decline, nothing happens, and the invite disappears. Next one, direct messages. Now, once all the pre-steps are done, searching plus invite accepted, we reach the core feature, a private one-to-one conversation between two users. Next, group chats. Of course, sometimes two people are not enough, so we also need a way to start a group chat with more than 2 participants. Membership is always explicit, you must be invited in. Nobody likes waiting, so our first non-functional requirement is optimization. Chats should open quickly, messages should appear right away, and moving around the app should feel smooth. Next one is offline mode. Even if the internet drops, users should still be able to read past messages. New messages can be typed and will be sent out once the connection comes back. Next, security. We need to keep things safe. User data should be protected, and nobody outside the chat should get in without permission. Reliability. Connections should feel stable. If the network blinks for a moment, The app should recover gracefully without losing on test. And accessibility. Everyone should be able to use the app. That means it should work well with screen readers, assistive tools and full keyboard navigation. To better show how our product works, let's picture the main parts of the app. On the left panel we have a search bar, the green one, a list of charts, like chart 1 and chart 2, and a button to create a new chart in the header. At the bottom there is an input box with a placeholder text and send button, so we can write some placeholder and we can add send button here. This is just draft. In the chat area, messages are shown with different alignment depending on who the sender is, like on the left side some messages and on the right side, for example, our messages. At the top we have also a header with chat title. If a user has just signed up and has no chat yet, they will only see the Create New Chat button. It will be just empty stage with one button. When they click on this button, a new screen opens for finding people, but for now let's keep it simple and not add all UI parts here. How our app actually talks with the server and keeps everything in sync. We can represent it in three main pieces. The first one is client. This is the front part, what the user sees and interacts with. It sends requests, shows messages and keeps the chat alive. The next one is server. This is the middleman. It connects our user to another, makes sure messages go to the right place, and applies all the rules like membership and invites. The next one is store. So, this is storage. This is where we keep user data, charts, and history safe. It's drawn as a separate block because it can live in different places. Before deciding where exactly to save our data, let's check the difference between client-side storage and server-side storage or databases. When it comes to storing chat data, we have two main paths. Keep it on the user's device or put everything on the server. Each has pros and cons, so let's break it down. The first one is budget impact. Client-side is cheap. The server only does hours, delivery and sync notifications. Storage stays on the device. Server-side is costly. It needs to store every message plus backups, scaling and fast databases. Storage limit on client side is limited by device or browser. It will be fine for tests, but not great for media heavy chats. Server-side grows with cloud or server capacity, basically unlimited if you are willing to pay. Offline support. Client-side shines here. Users can read and on-pause messages offline, then seen when back online. Server-side relies on on-state network unless hashed. Privacy. Client-side allows end-to-end encryption where the server never sees the actual messages. If hacked, attackers only see encrypted data. Server-side means trusting the server. Even with encryption at rest, data still lives there unless we go for full end-to-end encryption. Scalability. Client-side is cheap. It's cheap to scale, since the backend mostly pushes messages around. Server-side becomes expensive. With more users, more data, more reads, writes operations, and complex scaling. Performance. Client-side reads are instant because we have local data, no network delay. Server-side and feel slower because it always needs round trips for history. Because of budget limits, all messages will be stored on the user's device. The server only forwards messages between users. If a user is offline, the server holds the messages briefly until the user reconnects. Messages lives on the device. Profile or profiles are stored on the server, so the app keeps only what it needs. So, since we decided that we'll use client-side, let's move it here. But here we'll have one more version. On client-side, we encrypt our data in different storages like local storage, IndexedDB, or any other storage. So let's decide which one we'll choose. On the client side, there are two main storage options, local storage and IndexedDB. Both live in the browser, but they serve very different purposes. Local storage is simple and lightweight, while IndexedDB is more powerful and built for large datasets. Let's walk through the trade-offs. API type for local storage is a very simple a-value store. So let's write simple a-value store. You save and read text by E, like a small dictionary. Easy to use but very limited for big or structured data. For IndexedDB, a full object database inside the browser. It lets you store structured data, read many tables and run queries like a small NoSQL database. Storage limit. For local storage, it's around 5 to 10 megabytes depending on the browser. Enough for a few thousand text messages, but not for long history or media files. For IndexedDB, it can store hundreds of megabytes up to several gigabytes depending on the browser and device. Let's write 100 of megabytes 2 gigabytes. Enough for years of chat history and attachments. Data format. Local storage works with text. To store objects, you need to convert them with JSON stringify and parse them back when reading. For IndexedDB, it can store JavaScript objects directly, including nested fields, without extra steps. Performance. For local storage, it uses synchronous API, which means every read or write stops the main thread. Fine for small data but can freeze the app if you save too much at once. IndexedDB is opposite. It uses asynchronous API, so reads and writes happen in the background without blocking the app, making it smooth even with large data. For local storage, it doesn't support binary data. You can only store text, so images, audio and files cannot be saved directly. IndexedDB supports array buffer and blob, so you can store images, voice notes and other media files offline. Local storage is best for small pieces of data like settings, tokens or feature flags, good for app preferences but not for storing chat messages or media. Here in IndexedDB, it's large datasets like chat messages, media files and offline action. So this is the right choice for a real chat application. For storage limit, the number will be about 15,000. And here we'll have more than 1 million of messages. So I used the formula which was before. So I would say that here we have a winner, IndexedDB, which we are going to use. We decided that IndexedDB is the best choice. It handles large datasets, allows searching, and stores structured data more flexible than local storage. Now let's picture how the data flow looks and what kind of request the app will make. Number 1. So let's add here the arrow. The client app opens a secure HTTPS on actions. It sends login, details or a token. The server checks identity and gives access. So here let's write on edge and authentication. Number 2. Let's add one more arrow here. The app asks for active chats, recent messages and pending invites. So we need to get initial data. Also, we need to add 2 arrows here. So client request that we need to get data and server gets it back. This can happen over HTTPS. simple and reliable, or a WebSocket, more real-time. So it's time for another trade-off. Should we fetch initial data with HTTPS request, or keep everything on a WebSocket connection? The first topic is connection type. WebSocket creates a persistent, full duplex connection between the client and server. This means both can send data anytime without re-establishing a connection, ideal for real-time communication. REST uses stateless HTTP request. So every interaction requires a new request response cycle, great for predictable one-off operations. Latency. In WebSocket it's extremely low because the server can push data instantly without waiting for the client to poll. For REST, it's higher latency because the client must poll or refresh to check for updates, which adds delay. Efficient. We have in WebSocket bandwidth is efficient because it avoids HTTP headers for every message. After the initial handshake, only the payload is sent. Here we have higher overhead because each request includes HTTP headers, which adds up when sending frequent small updates. Scalability. In WebSocket it's harder because WebSocket connections are stateful and consume server resources. Load balancing requires sticky sessions or special infrastructure. For REST, it's easier because REST is stateless, so requests can be distributed across servers and cached easily. Offline. For WebSocket, it requires custom logic for queuing and retrying events when offline, then syncing when back online. For REST, it's easier because failed requests can simply be retried later without maintaining a persistent connection. Ideal for live message delivery, typing indicators, read recipients and presence updates. REST API is ideal for initial data sync, fetching all the messages and uploading, downloading media files. So here, for our sync operations, it's better to use REST API. So let's continue on our data flow. After sync data, we need to update our IndexedDB. So let's add a new arrow here and write update. So client writes active chats, participants role statuses into IndexedDB, save the latest messages per chat. Also it can remove any messages flagged as deleted by server. The next step is read out box. Client loads messages which we created while offline. So here we will write read out box. After reading, we open a WebSocket connection and send this data. Client sends each offline message with a temporary ID to the server. So send UID messages. And on this step, we open WebSocket connection. Then we receive acknowledge. So server validates and assigns real message IDs and timestamps. So here we'll need to replace temp ID on real ID. And we need to save this data as well. Next, I would say that it can be error from the server to the client. Here we receive any new live events, so server sends real-time new messages over WebSocket as they arrive. But it can be not just message, it can be any event like chat, something was deleted, or maybe some new invite which we received. So new events, but from others. As soon as something arrives, we update our IndexedDB. At the same time, if we have something to send, we need to do it as well. At the same time, we need to update our store. So here we use optimistic approach. It means that as soon as we have any message to send, we save this message to the IndexedDB first. Then we send this data with temporary ID to the server. We use this approach to don't wait until the server validates this data. In general situation it will be acknowledge, but we just don't want to show any loading indicators. So we save this data, update UI, and at the same time in the background we send this data to the server. At the same time to time, we need to do cleanup jobs. So client removes inactive chats and expired messages per retention policy. For example, we need to delete all chats which are inactive more than 6 months. Also, time to time server runs backend cleanup jobs as well for storage and performance. As a summary, IndexedDB is a local source of truth for offline mode and UI responsiveness. Storing chats, messages. Client sends data at start and on edge. Server is the authority for IDs, timestamps, membership and retention cleanup. This approach supports offline mode, real-time sync, data consistency, and scalable message retention, ideal for low-budget infrastructure. For data flow, I would say it will be enough. To understand what kind of data we are working with, it's helpful to look at the main parts of the app. We won't go through every single detail, but we will focus on the most important ones. First, we have the user profile. Let's zoom it. It holds three pieces of info: user ID, a unique ID for the user, display name, a name that looks nice in the app, and I guess that we didn't add to UI elements page this field, and searchable field. If searchable is true, the user can be found. If it's false, they are in the system but hidden. So it tells us if the user should show up in search or suggestions. This field can be changed on separate page, which we didn't implement, but in general it can be done on another page. Next, there is the invite. This is used when someone wants to start a chat with you. It includes ID, the invite's unique ID, status, shows if the invite is in progress, accepted or declined, created at when the invite was made, from and to user ID, who sent it and who got it. The invite can be shown on our UI elements page as something like it. UI will be different one here, so we'll have, I don't know, maybe some image, then title as participant name, and two buttons, accept or decline. The next one, we have a chat. This is the space where people talk. It has ID, a stable ID used across the app, name, this is optional, mostly for group chats, participants, a list of people in the chat, last message ID helps show a preview. Preview I mean here. So it can be name of chat and I guess something small here as the last message. And update add. It helps sort chats by recent activity. So for example, if we received the last message in chat 2, it can be sorted something like that. I didn't add participant interface, but it will be almost the same as user profile plus role, either admin or member, which helps with permissions. Finally, the most important part, the message. Each message includes, let's zoom it, the server's ID after sync, ID, temporary ID. This is a local ID used before sync. So, as I said during data flow, here we send this message with temporary ID. And then we receive a real ID and we replace it. So here we use this temporary ID, which will be replaced by ID. Chat ID tells us which chat it belongs to. Sender ID, who sent it. Encrypted payload, the actual message stored safely. So we don't store the message itself, we encrypt this message and then we save it to our IndexedDB. Timestamp when it was sent, read by a list of users who saw it. Status and be pending, sent or failed. Pending means it's waiting to be sent. Sent means it went through. Failed means something went wrong, we might retry or just show an error. From the interfaces, that's all. Since we'll be storing a lot of user data, we need to pick the right data structure. Messages can be stored as a simple array or with something like B-tree. Let's check the main differences. So let's go deeper into arrays versus B-trees for our chat messages. The first topic is memory usage. Arrays need the full chat in memory, all messages at once, so host grows linearly, or M. B-trees only load the part you ask for, like the last 50 messages, with host all again plus P. This keeps memory low even with millions of rows. Next is scalability. Arrays slow down as the message list grows, because every insert or delete means more shifting. Performance degrades linearly. B-trees scale much better. Their high grows slowly with data size, so operations stay all again even with large histories. Now inserts. With arrays, you first find the spot with binary search, to be O log M, if the data is sorted of course, but then you shift the rest of the list, which is OM, that's heavy. B-trees insert in log N, just walking down and placing one record. Delete. In arrays, removing one item means shifting everything after it. Again, O, M. In B-tree, you just remove one record, sometimes rebalance, so it will be O log N. For edits, arrays rewrite the whole blob, even if you change one word, so it will be O, M. B-tree do a point right on one record, so it will be stay on O log N. Next is search. Without a special index, both arrays and B-trees scan messages linearly, or M. But B-trees can use secondary indexes, making searches much faster when you set them up. Finally, pagination. arrays needs to load the whole list, then slice it. So it will be O, M. Bitrees and jump near the end in log n, and then stream p rows. That means smooth rolling even in long chats. So it will be O log n plus p. So the summary is clear. Arrays are fine for tiny, short-lived chats. But for a real chat app with long history, media, and a lot of users, Bitrees in IndexedDB win on every serious measure. Let's take an example with two chats. Chat 1 has messages at times from 1000 until 1005. Chat 2 has messages at times 500 till 502. We want to store all these messages so they stay sorted by chat and time, and so we insert fast. C1 means chat 1, C2 chat 2. This number is time. It's like seeing on the top box as a signpost in a library. It doesn't hold messages itself. It only points you where to go. The signpost has two split points. C1 1002 and C2 500. These split points divide the messages into three groups. Left group from we have all messages before C1 1002. Middle group messages from C1 1002 up to C2 500. Then we have right group. Everything after C2 500. So instead of searching through all messages linearly, the tree lets us weakly follow the right branch and find what we want to find in log n steps. Do you need to custom B-tree? Almost never. Everything is done in IndexedDB by default, so it already uses B-tree under the hood. Everything what it needs to provide the right interface. Here is an example how to do it. We have primary indexes for every entity. It will be ID. So every entity has unique ID. We also have secondary indexes. For chats, it will be update add. It lets you weekly sort or fetch chats by last update time. For example, for chat list ordering, which we discussed previously here and in interfaces section. For messages, we have chat ID plus timestamp, compound index that allows efficient pagination of messages in a chat. Range varies like last 10 messages from chat is. IndexedDB doesn't have a native offset like SQL. IndexedDB uses ordered indexes in B-tree, so you can start from a specific place and move forward. So we will not use, as you understand, offset pagination. We will use cursor pagination. We also have status field. It's secondary indices, but in our case it's optional. It's optional secondary index for quickly finding messages in a specific state, like pending. This setup supports both fast pagination and offline message tracking in a single store. So, primary indices guarantee uniqueness and fast lookup by ID. Secondary indices let you efficiently query and order data beyond the primary key or index, show charts by recent activity, fetch messages by chart in time order. So this is nice for storage and queries. But how do we subscribe to it? IndexedDB doesn't give us live events by default. So to listen in real time, we need our own events, or we can use broadcast channels. So let's take a look at another trade-off. Custom event versus broadcast channel. The first topic is op. Custom event works only inside a single document, a page or iframe. Broadcast channel works across all browsing contexts like tabs, iframes, workers that share the same origin. If two tabs are open on the same site, both will receive messages on the same channel. Next one is delivery timing. For custom event, it's sync. Listeners are called immediately during the dispatch event call. If one listener is slow, it blocks the rest. For broadcast channel, it's opposite. It will be async. Messages are queued and delivered through the event loop. Sending never blocks, and receivers handle them later. Workers. For custom event, it's only local to that worker. You can create and dispatch custom event in a worker, but it won't leave that worker. For broadcast channel, it's fully supported. A page and a worker can listen to the same channel. For custom event, we have full DOM event semantics. It can bubble, can be cancelled, and cross shadow DOM boundaries if on post true. For broadcast channel, it's not a DOM event. It doesn't bubble or use capture target phases. Listen with channel on message. For browser support, it's fully supported everywhere for custom event. For broadcast channel, it's supported in all modern browsers, including mobile and in web workers. Rule of thumb: use custom event when you only need to notify parts of the same page. It's fast, minimal overhead and DOM friendly. Use broadcast channel for ROS, tab, iframe or worker communication like scene chat state or shared storage events. And that's all for our store topic. So let's visualize it. And let's go to another topic. Let's add some obvious but must-have security improvements for our chat. And the first one is end-to-end encryption. This protects your messages while they travel from sender to receiver. Only the two devices can read them. The server in the middle cannot read or change the content. So let's visualize it here. Next one is client-side storage encryption. In our situation, let's maybe visualize it as well. This protects data that lives on your device, things like IndexedDB, hash or local files. Even if someone hacks your storage or you export it, all they will see is remnant data. Before saving, we lock the message with a secret. When reading, we unlock it with the same secret. Without secret, the data is useless. So maybe let's visualize some steps. So, first one, we make a secret. We can use some library or based on the user's password. When user sends a message, we turn text into bytes. So let's write text into bytes. Then we scramble it with the key which we created here on the first step. So let's write scramble it with the key. Then we save this remnant data. When we need it back, we take this remnant data, use the same key and restore the plain text. So take remnant data, we use the same key which we created on the first step and restore the plain text. If we talk about example, it's like we receive hello, we scrambled it, for example, to some string, and when we need it back, we restore it and we receive hello. But in IndexedDB we save only this string, like random string, not actual message. Okay, let's continue. The next one is metadata minimization. Yes. Metadata is info about the message, like who sent it, when, and to whom. Even if the text is encrypted, metadata and reveal patterns about your private life. So best practice keep only what's needed, like chat ID and timestamp. Avoid extra logs or IP. Next one is transport security. This is about protecting data while it moves between your device and the server. Always use HTTPS, so no one can spy or tamper with your message in transit. Secure push notifications. The next topic. On phones, push notifications often show previews on the lock screen, so never send raw messages through the Apple or Google services. Instead, send "You have a new message." Next one, validate user input. Users can try to send harmful or broken data, like massive files, strange characters, or even code, like JavaScript, SQL, etc. Always check message length, file size, and allowed characters. This prevents spam, rush, and some attacks. Next one, role model. Not all users should have the same powers. Like example, regular users can only send messages in their chats. Admins can add or remove members, and guests might only read. And the last one is enforce access control. On the server, even if the client tries to cheat, the server must check rules. The server ensures a user cannot post into a chat they don't belong to, or mark messages as read for someone else. Think of the server as a final guard that enforces all permissions. And for security, it will be all. Let's mark it. And we are moving to the next topic. Let's talk about how to optimize chat performance. It's a big topic, but we'll stay focused on the key improvements, just for chat, not fonts or bundles. And the first topic is message batching. When a user comes online after being offline, there may be thousands of pending messages. Batch them into one request or a few paginated requests instead of one per message. Sending them one by one over WebSocket creates thousands of frames. It will lead more network overhead. Next one is optimistic approach, or let it be updates. We already talked about this approach during our data flow here, but it's nice to mention it one more time. So we don't want the app to freeze while sending a message. So we add, maybe let's open this screen. We add the message right away with temporary ID and mark it as pending. So here we'll have pending messages. When the server replies, we update the ID and mark it sent. So here we read our outbox. Here we have some pending messages. Then we send it, and after it we replace temporary ID on real ID which we receive from the server. And we don't show the spinner when we send a message in this case. Since it's chat application, it wouldn't be a good idea. Next one is virtual plus infinities role. I guess every time when somebody says infinities role, they mean both approaches, virtual plus infinities role. So let's maybe repeat what is it. Let's open our UI here. So chats and have tens of thousands of messages. To keep things smooth, with infinities role, we load older or new messages only when the user scrolls up. So when we start scrolling, we load new data. With virtual role, we only show messages that are on the screen and reuse the rest. So it means that even if we load, I don't know, 200 new messages in the DOM in HTML, we always have, let it be 50 messages. So it's always the same number. That's the difference. So this keeps the app fast, even with huge chats. So let's continue. Next one is the debounced search, or let it be just the bounce. We split search into two parts, one for messages and one for new users. So we always want to have search by message, and we want to find a new user when we want to have a new owner, for example. Let's maybe copy this UI. Let's remove it and add our search. This is our search input. As we discussed, our messages are in IndexedDB. But what about profiles? Should we keep them in IndexedDB as well, or should we fetch new profiles from the server? Store user profiles. We have two main strategies. Strategy A: save all users in IndexedDB, like a full directory. Strategy B: save only the users you actually chat with, and the rest of profiles you will need to find through the server. Let's go through the points one by one. Storage usage. If we save everyone, storage grows fast and may hit browser limits. So here we will have high. Strategy B: we save only chat users, so it stays small and easy to scale. Here we will have low. Lookup speed. full directory gives instant search for any user, so it will be very fast. Minimal storage only gives instant search for your chat users. For a new chat, we ask the server, so it needs server hole. A big local directory and get old unless we see it often, so we have risk of stale. In minimal mode, server is always the source of truth, so data is fresh. Scene complexity. Directory needs background scene for thousands of users, so complexity will be very high. For minimal mode is much simpler, only a few profiles need updates, so it will be very simple. For privacy and security, saving everyone means more risk if device is lost, so it will be very large risk, I mean. For strategy B, saving only chat users is safer. Less data, less danger. So here it will be very small. For offline, with a directory, you can even start chats offline. So I would say full directory support. Minimal mode only works for known contacts. For most consumer apps, this is fine. But in general, it's limited. When is it good? Full directory fits small teams or enterprise use. Minimal mode fits public apps with millions of users. So, strategy B, this is our choice. So now let's visualize how it looks. Here we will have messages from IndexedDB. And here we'll receive profiles. We have one search, so I would assume that we'll have one component to show both data. For example, messages can be here and profiles here. It can be opposite as you wish. And some top messages here plus here. And now let's finish our optimization part. After the balance, I wanted to add scheduled cleanup. So we run a periodic cleanup. It can be daily. So we delete all chats or messages based on retention rules. The same we remove profiles with no remaining chats. It prevents storage bloat and keeps IndexedDB fast. So combining these practices give a fast, scalable and maintainable client. While we can talk about using the right colors, text sizes and contrast, today I want to focus on chat-specific accessibility requirements, things that make a real difference for people using your app every day. And the first one is show unread message total. So start by showing a clear total of unread messages. It helps everyone, especially those with vision or memory challenges. Know where to look. Next one, sort chats by latest activity. Keep the most active chats at the top by sorting by the latest message time. This saves effort and makes navigation simple. Next one, let's maybe change it. Give helpful empty and error states. So let's write helpful empty error states. Never leave users guessing. If a search finds nothing, say it, no results found. If something goes wrong, explain what happened and what to do. Next one, make messages reachable by keyboard. Let maybe just keyboard support. Every message should be easy to reach with the keyboard. This lets users move through the thread without a mouse, essential for screen reader users. Another one is announce system status. System status. When all the messages load, tell the user loading all the messages or 10 new messages added. This keeps everyone informed. Next one is ensure responsiveness or just responsive. Your chat should work on every screen size, desktop, tablet, and mobile. Responsive design isn't just visual, it's about making sure navigation and interaction remain easy for all users. So, accessibility is good design. These small steps make your chat app usable for everyone. That's it for this front-end system design. If you found it helpful, don't forget to like and subscribe to the channel. If you don't like, you can leave your feedback under the video. See you in the next video. Bye.